Okay, do you recognize this as your good old equation of a line? And your independent variable is x, and your dependent variable is y, and this is a function, a linear function. Well, sometimes instead of using y equals, have you seen it written this way? You've seen that, right? What this means is there is a function named f, and x is the variable, and this is the function rule. This basically means the same as y. Why don't I just use y then? Well, function notation, in my opinion, is really more useful once you get into upper level pre-calculus and calculus. But we introduce it in Algebra 1 and Algebra 2 so that when you get there, you realize it's just a way to name a function. This does not mean variable f multiplied by variable x. This is just the name of the function, and since math people are so creative, function, we named it f. And so this is the independent variable, that's all it means. And so over here on our notes for today, we have two functions. This table is named f, and this table is named g. This means the same thing as an xy table. And this means the same thing as an xy table. But by labeling it f and g, we identified which table we want to talk about. Now, these tables are functions. In a table, the way you tell a function is that you have no repeated x values. Do I have any repeated x values? No. That makes this a function. Do I have any repeated x values? That makes this a function. Well, what does f of negative 3 mean? Well, function notation looks like this. So do you see that the negative 3 is where the x is? That means in the function f, if x is negative 3, what's the y that goes with it? That means I'm going to look at the table labeled f. I'm going to look at negative 3 in the x column. What goes with it? This tells me I'm going to look at the table called G. I'm going to look at negative 1 in the x column. What's the y that goes with it? So looking at the table called G, negative 1 in the x column goes with this tells me to look at the table called G, look at 0, G of 0 goes with Now, before I do 4 and 5, which are a little bit more difficult, let's do a few more just function notation. F of 2 says, look at this table called F. Find 2, what goes with it? Is that pretty easy? Okay, what is this? Look at the table called F. Find the x value of negative 4. What goes with it? Is there an x value of negative 4? And so this is not possible or does not exist. There is not an answer to that. It's not possible. It's not part of my table. It's not part of my domain. Okay, well, what if this one's set up a little bit different? It doesn't give me the x value. It gives me the y value. In the table called G, if the y value is 4, what is the x value that goes with it? In the table called G, if I have a y value of 4, what's the x value that goes with it? Actually, there's 2 answers. There's a y value of 4 here and a y value of 4 here. So there's 2 x values that go with that y value. This tells me that this is the y value. In the table called F, is the y value is 2. What's the x value that goes with it? This is function notation. Now we're going to take our function notation and use our function notation for what's called compositions. Compositions is not adding, subtracting, multiplying, or dividing. It's a new operation, and let's see how it works. Here is the notation for a composition. It can be written this way or that way. They mean the same thing. Well, what do they mean? It means you substitute G into F. G is substituted into F. The inside function is substituted into the outside function. Well, let's look at what that means. This and this mean the same. 2 notations that mean exactly the same thing. If you have a number, you start on the inside. Just like we were doing previously, G of -3 equals what? Go to the table called G, find -3 in the x column. What goes with it? 2. Now, I take that answer that I got there and substitute it into the outside function. What's f of 2? I go to the function called f. I find the 2 in the x column. What goes with it? The composite of f of g of -3 is equal to -1. You find the answer to this, then that goes here, and then you find the second answer. That's what a composite is. You find the answer here and substitute that into the f. Well, what is g of -1? G, -1, goes with another -1. You take that answer and substitute it into the outside function. F of -1 goes with 0. You start on the inside. If you have a number to start with, you start on the inside. G of 0. What is G of 0 equal to? I look at this table called G. 0 matches with 3. That answer goes into the outside function. Now I look at the F function table. 3 matches with 2. All right, so when you have a number, you start on the inside, G of 4. I look at the table called G. I find 4 in the X column. 4 in the X column matches with -3. I put that -3 in the F function. F of -3 matches with 4. Start on the inside function, G of 1. What's G of 1? Then I put -5 into the function called F. Uh-oh. Do I have a -5? What does that mean? Not possible or does not exist. There is not an F of -5. Whether you have a composite written like this or like this, you start here. G of -4 is, is there a G of -4? I don't see one. I don't see a -4 in this table. So what does that mean? Not possible or does not exist. Okay, we're going to come back to 12 in a minute. Let's go on to 13. The F function does not have to be on the outside. This time the F function is on the inside, so I start here with the F function. F of -4 is equal to 3. Then I go to the other function, G of 3. What's that equal to? I start here. F of 1 is equal to -5. No, it's not. I looked at the wrong table. What is F of 1 equal to? F of 1 is equal to -1, and then G of -1 is equal to F of 1 is equal to -1. Then look at the table G. G of -1 is equal to -1 for your final answer. F of 4. Is there an F of 4? Does not exist, or it's not possible. Okay, what does this mean? Do I have a number to start here? I don't have an X. So I have to start on the outside, and this number is my Y number. F of something equals 0. If 0 is my Y number, what's my X number? In the table called F. Does -1, 0 match together? This, I did this function right here. Now I have to do what was the X value becomes the Y value. That's what makes it a composite. Okay, -1. Let's go back to this one that I skipped. I don't have a number to start on the inside, so I have to start on the outside. If this is my y value in the table called F, this is my y value, the x value will be, if this is my y value, the x value will be 3. Then that number becomes the y value, and what's the x value if the y value is positive 3? The x value is 0. If you wanted to check it, is that equal to 2? G of 0 would be a 3. Is f of 3 equal to 2? Yep. That is using function notation in composites with tables. What about if we have graphs? What's the name of this first graph? The first graph is named F. The second graph is named G. This means, look at the graph named F, go to x value of 0, what's the y value? Go to the graph named F, x value of 0, that would be here at the origin, what is the y value down here on the graph? -3, because I went down. This tells me on the graph called F, go to the x value of -5, find the y value. This is the graph called F, 1, 2, 3, 4, 5, -5x, and the y value is 1. This tells me go to the graph called G, and an x value of -1, and what's the y value? On the graph called G, x value of -1, the y value is 2. This tells me go to the graph called G, go to the x value of 2, find the y value. Graph G, x value of 2, positive 2, 1, 2, 3, 4. The y value is 4. Okay, that was function notation. Now we have to take that and do composites. Start here. When you're given a number, you start here. On the graph called G, if I go to the x value of 1, what's the y value? G of 1 goes with 5. Then composite notation says take that 5 and put it in the outside function. What is 1, 2, 3, 4, 5? 1, 2, 3. F of 5 goes with a y value of 3. This tells me to start in the function called g, go to the x value of -2. If I start in the g function and go to x of -2, then y will equal 1. That 1 goes into the function called f. Go to the other graph and go to the value of 1, and the y value will be -3. Ready for the next one? G of 0. Go to the graph labeled G, x value of 0, 1, 2, 3, 4. The y value will be 4. Take that y value to the function called f, and that y value becomes the x value. F of 4 equals f of 4 equals 1. This tells me where to start. Go to the function called g. 1, 2, 3, 4, 1, 2, 3, 4. G of -4 equals to +4. Take that +4 and put it in the function called f. 1, 2, 3, 4, 4 and 1. This says to start here, g of +4 is equal to -2. Take that -2 and put it in the outside function. Go to this graph and that will be a -2. We'll come back to 10 and 11. Let's look at 12. G of 3. G of 3, 1, 2, 3, 1, 2. Then this answer goes into the outside function. I go over here, x value of +2, y value of -3. This is where you start. G of -3. G of -3 is equal to 2. This goes in the outside function. F of 2 is equal to -3 again. Start here. What letter is this time? This is the f function, so f of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This number goes in the outside function. 1, 2, 3, 4, 5. 1, 2, 3, 4. I went down, so this is a negative 4. But on this one, I can't start on the inside because I don't have a number right here. So I have to start on the outside, and this number is my y value. So on the function f, I have a y value of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and a half. When I have a y value of 6, don't you agree that's about a 6 and a half? And then that becomes the y value for my inside function. One, 2, 3, 4, 5, 6 and a half. Do I have any graph up here at 6 and a half? Let's go back and do problem number 10. F of some number equals 5. 5 is my y value. 1, 2, 3, 4, 5. This would be a 6. This 6 becomes the y value for my function called g. What was x becomes y. That's what makes it a composite. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And so x would be equal to negative 5. Let's go ahead and let you practice on assignment 4-1A. 4-1A. Oops.